If we see the internal part of the operation amplifier, so basically in the operational amplifier, this is your symbol. Okay, these are the two terminals. This terminal is ground, battery, in one resistor. Okay, that is called the R in, R out. Okay, if I say this is the positive volt terminal, this is the negative terminal, this is the V1, V2. The voltage drop across R in is, the voltage drop across this resistance is the difference between two terminals voltage. So that is V1 minus V2. Okay, and this voltage source will be A times V1 minus V2. Okay, so this is basically the internal diagram. If you see anywhere in the operation amplifier internal part of that one. Okay, so the diagram should be like that. Now we consider that if my op amp is ideal, okay, the current, incoming current is zero. Okay, incoming current is zero. That means the current here will be I is equal to zero. So what is the value of I? The I is nothing but V1 minus V2 by R. So two assumption we are taking here. The current I is zero when V1 is equal to V2. Okay. And second, the current I is zero when R is infinite. Okay. Any doubt? Yes, any doubt?
No, sir.
No, sir.
Okay. So if I say that V1 minus V2, this is called the virtual short point. Okay. Or it is also called the virtual ground point. Virtual short and virtual ground. And R is infinite, that is called the infinite input resistance. Okay, so these two scenario we will generally taken. So op amp has always infinite input resistance. Now we talk about the output. Okay. Now what we consider that any particularly voltage, if I getting V1 minus V2, if I apply the V1 minus V2, we are getting the maximum voltage A times V1 minus V2 here. Okay. So A times V1 minus V2 will be this battery. This battery will provide me the A times V1 minus V2. Now the all voltage that will be here generated by this voltage source, it will be apply or basically appear at the output point. That means the voltage drop across this one is V drop is almost zero. Then if there is a particularly voltage drop here at R out, so we are getting the output voltage is A times V1 minus V out minus V across R out. That is the output voltage. Okay. So we have to eliminate this term V R out. We have to eliminate this term. So we know that V R out is approximately 0. That means I times R out is approximately 0. Okay. So there are two reasons. The current I is 0 and second R out is 0. So current I is 0. That's why we say that no current flow inside the op amp. Okay, and R out is 0. That's why we call the 0 output impedance. Okay, so there are the 4 or 5 points if we are talking about for the ideal op amp. The R in is infinite. That means infinite input impedance. R out is 0, 0 output impedance. First, current flow, so I is 0. That means current flow inside the op amp is 0. Okay. V1 is equal to V0 virtual ground constant. Okay, understood? Any doubt till now? You just ask. Yeah, any doubt?
No, sir.
Okay.
No, sir.
Now, if I say the current flow is 0, so this is my op amp. if I apply any terminal voltage, like for example, this is my positive, I apply V1 here, that is connected with ground. Okay, for example, I'm just kidding. So if V1 is 0, then output voltage V out is A time, we mentioned that A time V1 minus V2. But where is the path to flow the current? Because we are already saying that if we are consider the ideal op amp, that means no current flow inside the op amp, through the op amp. If no current flow through the op amp, that means where is the path that V1 will be traveled to the V out. Okay, so that's why one feedback is required. That's why the feedback is required. Okay, through this feedback, this current flow from here to here, and that will be appear in the output as V naught is equal to A times V1 minus V. So feedback is required. So op amp mostly used in the feedback part.
Sir, please explain why do you use feedback path?
Yeah, why we are saying, okay, this is the ideal op amp conditions we are discussing. Rn is equal to infinite, R out is equal to 0, I is equal to 0, and V1 is equal to V2. Any doubt in this one?
No, sir.
Okay. So if I say that current flow inside the op amp is 0, so here no current flow. Okay. This V1 will be coming from here, but this particularly block, I am not using the op amp, I am using the one block here in place of op amp. Okay. And if no current flow inside that one, so I just compare that one with the insulator.
Yes, sir.
Okay. And what is the property of the insulator? If you apply some current, it will not follow the current, and here we are getting I is equal to 0. So that's why insulator is used to basically avoid the shocking condition, electrical shock.
Yes, sir.
Okay. So from where the current will be flowing? So there is one path is required to flow the current.
Okay, okay.
Otherwise,
That-
we are applying the either V1. If I say this one, I apply the either 2 volts, 3 volts, 4 volts, any of the voltage I apply, we are not getting any. Okay, so that's why feedback is required.
Okay, sir. Understood.
Feedback is not required in one condition. You will discuss this condition in the your experiment when you do the analog lab part. Okay, feedback is not required when op amp is used as a comparator. Okay, so when we are discussing the lab part, we will discuss this one, op amp as comparator. Okay, feedback is not required when op-amp is compatible. Otherwise, we require the feedback. Okay. Now, any doubt?
No, sir.
Yes, any doubt? Now, shall we
Yes, sir. No
proceed?
doubt. Yes, sir.
So here one concept is coming, that is the feedback concept. What is the feedback? What is the feedback? Anyone? Anyone? What is the feedback? Okay. So I'm just giving you one example is that I taught this subject, analog electronics subject, okay, to you. Okay, so after a 2 or 3 class, I take a feedback from you. Okay, and you are saying that, sir, this topic is we are not understanding, or basically, this thing we have to more require more emphasis on that one. Okay, so on the basis of that one, what should I do in the next lecture when I am taking after feedback? I just do some changes in my lecture teaching methodology, or basically change the topics for a better clarity, for a better understanding of you about this subject. Okay, so that is a simple feedback. So like if I draw this one in the block form, so I am a teacher. Okay, I will deliver you something, and that is the output. Okay, after some classes, I take a feedback from you, and according to this one, my delivery will be changed with the original delivery. This is the change delivery content. This is the original delivery content. Okay, and that is the feedback from it. Okay, any doubt?
No, sir.
Okay, now the thing is that the student who give the feedback, that may be two types of feedback. Either that feedback is a positive feedback, or that feedback will be the negative feedback. If the positive feedback I am getting from the student, I will increase the level of my delivery content. Okay, like for example, everyone says that, oh, sir, we are fine with the your delivery part. Okay, there is no issue, everyone says this thing. So what happened in that scenario, my original delivery content directly goes to the change delivery content. Why? Because there is no feedback, no requirement of any improvement. Okay, but some says that, sir, we are having a problem in this particularly part, we can't understand this thing. Okay, so what should I do? I have to change my delivery content. I have to go back my previous lectures or basically reduce the level of teaching, so you will get a better delivery. Clear?
Yes, sir.
Okay. Now, if this is a normal journal feedback system, now if I take that one for the automation part, for the electronics part, so everywhere we require the feedbacks. Okay, like for example, I just operate a fan. This is my fan. Okay, I am getting the output of as a form of fan speed. There is one person X, user X. Okay, there is one user X. What happened? Sometime user X feel that fan speed is too fast. That means he is feeling little bit cold. So what should he do? He basically reduce the fan speed, reduce the voltage. Okay. Here after user X, they will regulate, use a regulator. So that regulator will be either increase the voltage or decrease the voltage. Okay, reduce or increase the voltage. Increase or reduce the voltage. Okay, like for example, my fan is on speed 3. Okay, and I am the user. I feel that this is too much cold. What should I do? I just rotate the regulator at 2. So that will reduce the voltage, and if voltage will be reduced, the fan speed will be down. Okay, the fan speed will be down. After some time, I feel that it will be hot. So what should I do? I just increase the regulator. So basically, voltage will be increased, and that will be increase the speed of fan. So I am getting a normal temperature. After that, again, so basically, this is the loop. Okay, this is the loop. Now the two possibilities are there. Either the feedback voltage is added or subtract. Okay, added or subtract. If the feedback voltage is added, that means input and feedback are in same phase. That is called the positive feedback. Okay, and when we use the subtract, the input and feedback are in out of phase. Okay, out of phase. So that is called the negative. Okay, so I am taking, this is my V in, here I am getting VE, this is my forward gain. Generally it should be represented by A, this is output, V out, here we are getting the feedback gain. It is mentioned in beta or sometime it is mentioned in the F form. Okay, so what is my V out by V in? If you go through with the weak content, what is my V out by V in? Yes, if you go through with the weak content, what is my V out by V in?
Gain ratio.
Gain ratio. Okay. Anyone knows the formula? Remember the formula?
A upon 1 is A beta.
So basically, V out by V in is A upon 1 plus A beta or AM. Okay, how we solve that one? So first of all, we calculate the V. V is my V in minus beta time V out. Okay, if V out will be coming here, so this is the beta time V out. Okay, and V out is A time VE. So I put all the values in this equation. So A time V in minus A beta time V out is equal to V out. So I am taking the V out as a common. So 1 plus A beta times V out is equal to A time V in. So V out by V in is equal to A upon 1 plus A beta. Okay, so I am considering here the negative feedback. Okay, I am considering here as the negative feedback. If I consider the positive feedback, so that means this V beta V out will be added with VE. So VE is equal to V in plus beta V out. Okay, and if I solve this one, so V out by V in is equal to A upon 1 minus A beta. Okay, and if A beta is equal to 1, I can say the VA out is equal to infinite. That means without V in, you are getting V out is equal to infinite. Or a minimum V in. Okay, without V in or a minimum V in, you are getting the V out is infinite. So basically, we use the positive feedback in the part of oscillators, but that is not covered in this If we design oscillators, we require a positive feedback, otherwise we generally use the negative. Any doubts? Yes, any doubt?
No, sir.
Okay. Now, how we check the feedback is negative or positive? So, like for example, I'm giving a block diagram. This is the A. This is the F. Positive, positive. Okay, how we check how or basically how we identify the feedback is positive or negative? So, as already mentioned in the lecture, just break the loop. This is your loop. Start from the adder to A, then feedback to F, then again add it. This is your loop. To break the loop. Okay. Apply a small incremental voltage. What is the incremental voltage? A little amount of the voltage you have increment. Okay, so that will be a small incremental voltage. And check when you come at the other side of this part, okay, other side of this loop, you are getting the direction of your signal either in the positive or in the negative. Okay, so you increase the voltage. Okay, small increment voltage here, the voltage will be increased. Now F. Okay, if F is positive, you are getting the voltage positive here. Okay, magnitude is maybe increase or decrease, that is dependent on the value of F. I am just considering the F is positive. So if F is positive, you are getting the positive voltage at the output of F. Now here it will be added, so that means you are getting a positive voltage here. Okay, I am assuming that this is 0. So you are getting a positive voltage. Now again A, if A is positive, so you are getting a positive voltage here. Okay, I am not taking the amount, I am only considering the direction of voltage, either it is positive voltage or the negative voltage. So you can see no phase shift. That means positive feedback. Okay, second case, I just assume the F is negative. Okay, so incremental voltage I am added. Here the voltage is incremental because passing through the F, we are getting a negative voltage. Okay, negative voltage here. Now it will be basically no change in that one. So here we are getting the negative voltage. Okay, if it pass through the A, we are getting a negative voltage. So this is the phase shift. Third case, we are taking F as a positive and A as a negative. So positive voltage we apply, the positive we are getting here, the positive we are getting here, the positive we are getting here, the positive we are getting here. But because multiply with A, we are getting a negative voltage. Okay, so this will behave as a negative voltage. Okay, any doubt? The fourth case, when A and F both are positive,
Sir,
but we use the
third one.
subtractor.
Sir, please explain third one.
Yeah?
Third one, that is positive. Uh,
Where?
to third option.
Yeah. Third option, okay. So both
Okay.
A and F is positive,
Yes, sir.
and we subtract the signal. You are talking about this option now?
Yes, sir. Yes, sir.
Okay. So here we are getting a positive. Here we are getting a positive. But because of this subtraction, we are getting converted into the negative. Now negative multiply with the positive, we are
Yes, sir. Yes,
okay.
sir.
So
Yes,
there
sir.
is also a equation. So either A is negative, either F is negative. As feedback signal where the summing will be done, that is negative. So that will be decided that the signal will be the negative and we are getting the negative. Okay. Now this is the block diagram. If I go with the feedback path of a PAM, now identify the terminals. Yes, identify the terminals. Yes. Anyone identify the terminal? Okay, so how we check that which is terminal is the positive, which terminal is negative? So I just consider this is the V out. Okay, this is the loop you can see. Now I just break the loop, increase some voltage. Okay, incremental, apply incremental voltage. Now, what is the voltage at this point? If I say the increment voltage is VA, okay. So what is the voltage at this point? VA into RB upon RA plus RB. Okay, that voltage is applied here. So we are getting the voltage. I just say the VB voltage. Okay, so the voltage is VB voltage. Somehow the amount of VB is reduced, but again it is in positive. Okay, so this is the VB voltage. Now, if I consider this is the positive terminal, so VB multiply with positive terminal, we are getting a here a positive VB. Okay, and if it is a negative terminal, so VB multiply with negative is a minus VB. Okay, now if we compare these two, the amount will be reduced, but the direction of voltage will be same. So that will be considered as a positive feedback. Okay, and if I consider these two, the amount is reduced as well as the direction of voltage will be also reversed. So that is the negative feedback. Okay, so for negative feedback, this terminal should be negative, this terminal should be positive. If anyone have any doubt, you can ask. Just if anyone have any doubt, you can ask.
Sir, there is no function for RC.
There is no, but yeah, exactly. Because what we are saying that no current will be going here.
Okay.
Okay, no current will be going here. So that means from this point to this point, no current will be passing. If current is not passing, so voltage drop across RC is zero.
Yes, 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 sir.
Okay, but anyhow, we are not considering this thing also. If there is some voltage drop across RC is also there, but the direction is again same. Okay,
Yes, sir.
right now we are only checking that the feedback is positive or negative. Maybe somehow there is a change. We are not considering what are the changes of it or what are the effect of RC here. We are only saying the voltage will be same. Not same. Basically, the magnitude is different, but the direction of voltage will be same.
Yes, sir. Okay.
Okay. Resistance never change the direction and never create any phase shift in that one. If there is some capacitor or there may be some inductor, so we will consider that there may be change in the direction.
Yes, sir.
Understood?
Yes, sir. Understood.
If I take one more case, Identify the terminals for a positive negative feedback. The method is same. First of all, identify what are the loops. So here two loops are created. One is this loop and second is this loop. Yes, identify the terminal of first operation amplifier. Yes, anyone? How we find? Yes, anyone solved it? Yes or no? Student, if you have any doubt, you can ask. Anyone? Student, if you are not getting, just tell me that. So can you solve it? The first loop is basically the negative. Okay, you can check that first loop is already a negative feedback. If we talk about the second loop, just break from here, increase the voltage. Okay, so voltage will be here high. The voltage at this point is, sorry, not high, positive, positive, positive. Now if I consider this is a positive, so we are getting a positive voltage here. Again, it will be go to the positive terminal. So we are getting a positive voltage here. Okay, and if it is negative, so we are getting negative voltage here. Again, negative will be go to the positive. Here we are getting negative, and negative go to the positive. Again, a negative voltage. So this is the condition, and that condition arises when this one is a negative and this one is a positive. Okay, if identify the terminal for negative feedback. Just identify. Yes, now it is clear how we identify. Vx is positive. Someone says Vx is negative. Okay. So Vx is negative and this one becomes positive. Kindly check. Yes, kindly check. Vx is negative and other terminal is positive. Anyone? This one is the correct or wrong? Okay, so there are again two loops. For the first, sorry, for the second op amp, we see that negative will be connected in the output. Okay, so that means if you break the loop for the first, the second one, break the loop, increase the voltage, it will be go increase here, positive here, it will be positive here, multiply with negative, so it is a negative. So second one is the already in negative. Okay, for the first one, this particularly, so break the loop, increase the voltage, it will be increases here, it will be increases here. Now if I consider the positive terminal, it will be increases here. Okay, and this increase here, multiply with negative sign, so decrease here. Okay, and if I consider the negative, okay, if I consider the negative, so this increase multiply with negative will decrease, it will be go here decrease, and again multiply with negative, so it will be increases. Okay, so it will be now a positive feedback. Okay, because two negative is in the feedback. For the first op amp, two negative terminal in the feedback. So two negative will be multiply and will become a positive. Okay, so we are getting the same phase signal at the output. Understood? So that means where the Vx is connected, this terminal is negative and the other terminal is positive to maintain a negative feedback. More questions is required for understanding this concept, or that is fine? Yes, you required a more number of questions. Okay, fine. Now after that we go with the inverting and non-inverting amplifier. So this is my op amp. We saw that we apply a two inputs. One is the V1, one is the V2. In between them, one resistance is connected. Okay, so one terminal is positive, one terminal is negative. Okay, you can switch these also, no problem. Terminals, one is positive, one is negative, because when we use the IC, in the IC positive and negative terminal are fixed. But this is only the representation, so you can draw in this way also, no problem with that. This one is positive, this one is negative. Okay, the positive terminal is basically called the non-inverting terminal. Why we call the non-inverting terminal, we will discuss. Okay, and the negative terminal we call the inverting terminal. Okay, if we apply a input on a non-inverting terminal, then this type of amplifier is called the non-inverting amplifier. Okay, and if you apply the input on the inverting terminal, we call them the inverting amplifier. Okay, so there are two types of particularly configuration we can use. One is the inverting, one is the non-inverting amplifier. Okay, so in the week one, we already only cover the non-inverting amplifiers. For the consider of non-inverting amplifier, just remember always we use the negative feedback. Any amplifier, not a non-inverting. If we are using the inverting amplifier, we always use the negative feedback. Okay, positive feedback will be used in week 3 when we are discussing the estimate trigger. Okay, and threshold level. So that is only in that scenario we consider the positive feedback. Otherwise, we consider every time is the negative feedback. Okay, so for non-inverting amplifier, we could just basically maintain the negative feedback, and if it is a negative feedback, we have to maintain the virtual ground also. Okay, so if I say to my op-amp, that is grounded, Vout minus plus Vi. Okay, that is the, I just consider RA, RB, and RC. Okay, so this configuration is called the non-inverting amplifier. Why? We maintain the negative feedback. Just check, break the loop, increase the voltage. Voltage will be increases here, voltage will be increases here, multiply with negative, voltage will decreases. So maintain negative feedback. Second, applied voltage at positive terminal. Clear? Now the thing is that how we solve it. How we solve. So basically, we already saw that if we are using the op-amp in a negative feedback, that means no current go inside op-amp. No current go inside the op-amp. Okay, so if no current going inside the op-amp, so this is I is equal to 0. So if I is equal to 0, that means the I from this one is also 0. If I from this one is 0, so the voltage drop across this VRA, that is also 0. Okay, so that means this point voltage is also VI. Any doubt? Ask. No doubts?
No doubts.
Okay. So this point voltage is also VI. So now virtual ground. What is the virtual ground concept? The positive terminal is equal to the negative. So if this point is VI, so this point voltage is also VI. This point voltage is V0 and this is ground. Can you apply the KCL? I just assume the current that is coming from here, it will be go in this direction. Okay. So if I apply the KCL at this node, so the incoming current, I just say this is the incoming current I1. This is the outgoing current I2. So at node Vi, the incoming current I1 is equal to outgoing current out2, I2. Because no other path. There is one path is also there, but we already say that the current inside the op-amp is 0. Current inside the op-amp is 0. So that means this path current is 0. So the incoming current that is coming from ground through RB, it will be passed through RC. Complete current. So I1 is equal to I2. Now what is I1? 0 minus Vi upon RB, that is equal to Vi minus V0 upon RC. Okay, so it is a minus Vi upon RB is equal to Vi upon RC minus V0 upon RC. I take this term this side and this term to this side. So V0 upon RC is equal to Vi 1 over RB plus 1 over So V naught upon RC is equal to VI RB plus RC upon RC. RC and RC cancel out, so V naught upon VI is equal to 1 plus RC by R, or V naught is equal to VI 1 plus RC upon R. Now the RC is generally it is feedback. Okay, RC is the feedback. So you see that V naught is equal to VI 1 plus feedback resistance upon input resistance. Okay. Now if you remember the first circuit that we draw about the operation amplifier, this one. So output voltage is A times V1 minus V2. Okay, so V naught is equal to A times V1 minus V2. Now V2 is grounded. Negative terminal is grounded. So that is equal to A times V1. Now can I compare this one? Is it VI 1 plus RF upon RI. So V naught is equal to VI times A, that is equal to VI times 1 plus RF by RI. So the output voltage is dependent on gain A, and that is equal to 1 plus RF by for a non-inverting amplifier. Now the point is that why we call that non-inverting amplifier. So if you see that the V naught and VI both are in same phase, there is no minus sign. Okay, if I apply the input voltage, so we are getting the same phase output voltage with some gain, and that gain is 1 plus RF by R1. You know that 1 plus RF by R1 is always a positive, because RF by R1 resistance value is always positive, 1 is always positive, so 1 plus RF by R1 is always positive. So that means if we apply the input positive voltage, we are getting the output is also a positive. So that's why we call that it is a non-inverting amplifier. There is no inversion between the input and output. Okay? Yeah. Pradeepa, you can ask. Pradeepa and Prince.
Sir. Sir, please explain the current part of the
Okay.
closed loop system.
Okay. I just in this figure or some other figure?
In the same figure.
Okay.
Like in the case of the negative feedback,
Hmm.
if the operational amplifier is ideal in nature,
Uh-huh.
then the current is always zero or maybe none.
Inside the op-amp current is always zero.
Can you explain it again?
We are yeah, okay, I will explain. Yes, Pradeepa.
Sir, can we solve one more question to
Yeah, we will solve
find the terminal?
one or two more questions.
Okay, sir.
So yeah, so again we go back into the starting part, operation amplifier. Okay, so in the ideal op-amp, what we consider the input resistance is infinite. Ri is
No.
the infinite.
Sorry, sir, to interrupt you. I am asking about the closed loop system, not for
Yeah,
the
yeah, yeah.
open loop system.
Okay, okay, I will tell that also. So the initial condition for the R in is infinite. Now, if we go with the closed loop part, this one. Okay, so what we assume that we are using operation amplifier always in negative feedback. Okay, and in the negative feedback, we generally consider the virtual ground concept. This is the way to solve a operation amplifier. Okay, not in this one. When you go till week 11, only the method is that you have to maintain a negative feedback. Okay, and in the case of negative feedback, you always consider a virtual ground concept. Okay, what is the meaning of virtual ground concept? Both terminal voltage is same. Okay, I just show one more diagram. The diagram again. So what I in the negative feedback is that this terminal voltage and this terminal voltage is same. Okay, if both terminal voltage is same, we are saying that internally it is a resistance. So if both voltage is same, that means no voltage drop across this resistance. It is only possible when. Okay, I just saw that this is my terminal
Internal
1.
resistance is infinite.
This is condition. Okay, these 2 points and the resistance. If I say this is V1, this is V1, when it is possible,
If internal resistance is
current
infinite, that is like a short circuit.
current is 0. If I say the internal resistance is infinite, so if R is infinite and open loop, so I apply V1 here. This is my open loop, that is V2. So my overall complete load, basically voltage will be dropped here because it is infinite. Rn is infinite, so that means the voltage drop across this one I is basically 0, but voltage drop V is equal to I times R. So what we assume that overall voltage will be drop across here. That's why we are not getting any voltage here. Okay, I just take a one more case. Simple, go back to the circuit part. This is R1. This is R2. Connect it back. Okay. So now here is the voltage of VR1. Here is the voltage of VR2. So overall voltage V is equal to VR1 plus VR2.
Yes.
Okay. Now I just do a short. I just make a short. So V is equal to VR1 plus 0.
Yeah.
Okay. So that means overall voltage will be drop across this R1 resistance. Now we make it open. Now V is
Itself V.
V. Okay. Basically no current will be flow. We are saying no current will be flow. I is 0 because it is an open loop.
Yeah.
Understood? Yes.
Yes, sir.
Okay. Now, if current is 0, can I assume that this voltage is again a V with the same polarity?
Yes, sir.
So V minus V divided by R1 is 0. So current I is equal to V minus V divided by R1, and that is 0. So basically, if it is an open loop, that means our maximum current will be drop across this one. Clear? Now we go back to this part. Now, if this particularly is the infinite or behave as an open loop, that means the maximum current will be drop across this one. All voltage will be drop across this one.
Sorry, please repeat again.
If I assume that this is the open loop, I apply V1 here. So we are getting 0 here, and V1 drop is here. Across this open loop. This diagram. V1 I apply here, it is I apply 0 here. So I am getting the V1 voltages drop across the resistance, infinite resistance.
Okay. Okay.
Okay. If this is V1 and this is also V1, so the current is I is 0.
Yes, sir.
So basically from these two terminal, no current will be going inside this op amp. I is 0, I is 0. Now what is the way to pass the current? The only way to pass the current is this one.
Yeah,
Clear?
got it. Means we can say that in the ideal uh, operational amplifier, the current through the terminal, it is
Yeah,
always
inside the
zero,
op
right?
amp is 0.
Yeah, that the terminal across the operational amplifier, the current will be zero, right?
Yeah.
Okay, got it. No matter what, in there were a register or something.
Yeah, no matter about that one. Okay. Some circuits,
Means
like there are some other path is also available, then we can't say that the current is 0. Okay, if there is a other path, like for example, if I say there is this path is not available, this feedback path is not available. Okay, so the current here is 0. Why? Because this is the grounded. This terminal we say that already the current is 0. So basically the current in this branch is also 0. I is 0. But because of this path, because of this V out voltage, the V out will be passing through this to ground. So maybe there is some current. Okay, if
means
this
maybe
path is not available, if this path is not available, We consider the current in this branch is also 0, current in this branch is also 0.
That was my question. If the feedback is present, then the current through the operational amplifier.
Inside the
May
operational amplifier is 0. Always.
Can you solve one example?
Yeah,
With the
I just
numbers.
take one more example. I just take one of them. This is positive terminal. This is positive. I apply a 1 volt signal here. Okay, I just take values also 1 kilo ohm, 2 kilo ohm, and 5 kilo ohm. The same question I am taking with the values. Okay, right now I am taking same question with the values. I am not going with that complex circuits.
Okay.
Okay, so now you can see that what I say is the operation amplifier, the negative feedback is available. Okay, so negative feedback is available. If negative feedback is available, we consider the virtual ground. That means the voltage at this point, I consider the V1 or V plus. The voltage at this point, I consider the V2 or V minus, both are equal. Okay?
Yeah, proceed. Yeah, proceed.
If both voltage are equal, that means no current go inside the op amp. So that means I can say the I is 0. Inside, I inside, not exactly I is 0, I is not mentioned, the I inside is 0. Clear?
Yes.
Because the value of I is what? If I consider this is the input resistance, this is the R in input resistance. So what is the value of I inside?
0.
V1 minus V2 divided by R in. So if V1 minus V2 is 0, I am not considering this is the basically ideal op amp where the R in is infinity. Okay, there may be possible some R in. Okay, so if V1 and V2 both terminal voltage is equal, so I inside is 0. Clear?
Okay.
Now
Means
if
the in the yeah, proceed.
if no current going inside this one, so that means for the positive terminal only one path is available for flowing the current. Okay, and we say that if no current will be flowing inside the op amp, that means no current flowing from the 1 kilo ohm resistor also. So this I is also 0 across 1 kilo ohm. So I across 1 kilo ohm is also 0. because there is no other path. Okay,
Yeah,
any doubt?
got it. For at the node where the 2 kilo ohm and the 5 kilo ohm
Yeah, I just
resistor
go with
meet.
that part. I go with that part also.
Okay, proceed.
Okay. Now we are saying that no current going inside from, so upper part is clear.
Yes, sir.
So we can say that V1 is again a 1 volt. Why? Because the drop across this one is 0. If current is not flowing, so the drop across 1 kilo ohm is 0. And if drop across 1 kilo ohm is 0, so that means the current that we apply, all complete current will be appear at this point. So V1 is 1 volt.
Yeah, clear.
Okay. Now if V1 is 1 volt, so we say that V2 is also 1 volt because of virtual ground.
Yes, sir.
Now the path is that. We know that inside no current will be flowing. We know that current will be flowing in this way, in this way, and in this way. Or we say that if this V2 point and this point both are shorted, so that means this point voltage is also V2.
Yes, sir.
Okay. If this point voltage is V2, then that means from the V2, one current will be going inside the ground and one current will be going towards the V out. If V out is greater than V2, now the conditions, two conditions are there. If V2 is greater than V out, that means the direction of 5 kilo ohm resistance. So I across 5 kilo ohm resistance will be from V2 to V out. The direction, I am only explaining the direction. Because the current always flow from the higher potential to the lower potential. If V2 is greater than V0, we say that the current across 5 kilo ohm will be the toward the output direction. Okay,
Yes.
understood?
Yes, sir.
And if V0 is greater than V2, the current across 5 kilo ohm resistor will be passed from V0 to V2 direction. Which one is the higher? According to that one, the current will be going. Now I apply the KCL. At V2 node, I apply the KCL. Why? Because there are two currents. And I just assume that both current will be going upward, away direction. That means one current is going from V2 to ground and second current is going V2 to V0. Because we don't know the V0. So we are saying that V2 has a 1 volt potential, so the current will be going from V0 to V2 to V0. So can you apply the KCL at this point? Both are the outgoing current. I just say this is the I1, this is the I2. Okay, so I1 plus I2 is equal to 0. I think you are familiar with the KCL. All the incoming currents or all the outgoing currents should be equal to 0.
Yes, sir. Nodal analysis.
Nodal analysis. Okay. Any doubt in KCL part?
And no, sir.
Okay. Now what is the current I1? That is going from V2 to ground. So one potential is V2, second potential is ground upon 2K. Plus what is I2 current? That is going from V2 to V0. So V2 to V0 divided by 5K is equal to 0. Now you can solve the V2. We know that 1 volt. So apply the 1 volt here. 1 volt. This is also 1 volt. Can you calculate the V0?
Yeah.
That is a mathematical calculation. Understood? Any
Yes,
doubt?
sir.
Now I
Like
just
in the
yeah.
short circuit, the value of current will be anything, but in the virtual circuit, the the value of current will be zero, right?
Yeah.
Okay. Thank
Now
you.
I take one more case. This is my positive terminal, negative terminal. Now we know that at this point and this point voltage is same. Okay. The current
Yes.
inside this one is 0. But current from this one is not equal to 0. Why? Because there is one path is created. Understood?
Yes, sir.
Now you see that there are two particularly uh, two particular loops are created, one through the positive, one through the negative. First of all, we check that circuit is a negative feedback or not. Okay, so I just put the values here. That is the 1K, 10 kilo ohm, 4 kilo ohm, and 2 kilo ohm. Okay, I break the loop. Okay, so we go with the both loops. One is the positive, one is the negative, and check where we get the maximum negative voltage. We consider that particular condition. Okay, I just
Sir, why negative?
then we consider the negative feedback is there, correct or not.
Like
Okay, just
here,
wait a minute. Wait a minute.
here
I
we
just call.
get the okay.
You are getting that we are applying both terminal. One is the positive terminal, one is the negative terminal. Okay, loop are connected with the positive terminal as well as the negative terminal both. For example, I am getting a 5 volt here and 4 volt here. What is your output? I apply 1 volt here and I am getting 5 volt and 4 volt here. So what is your output? V2 minus V1. What
Yes.
we do? Output is A time V1 minus V2.
Yes.
Okay,
Basic operation.
so this is A. So A times V1 is 5 volt and V2 is 4 volt. So A times 5 minus 4 is A. That is also in positive. So you are getting a positive feedback. So that means circuit is wrong. Understand
Sorry, sir.
or not?
Sorry, sir. I didn't get it.
Okay, you can get it. I just go. Okay, I just apply 1 volt here. Okay, and after all calculation, I am getting 5 volt here and 4 volt here. I am just taking the assumption. I am not solving this circuit right now. I am just assuming that I am getting 5 volt here and 4 volt here. Is it clear?
Yeah.
What is output voltage? Output voltage is A time V1 minus V2, or A time V positive terminal minus V negative terminal.
Yes, sir.
What is V positive terminal voltage? 5 volt. What is V terminal
5.
negative terminal voltage? 4 volts. So what is your output here is A times 5 minus 4, that is A times 1. Again a positive.
This means this is a positive feedback, right?
Yeah, this means this is a positive feedback. Okay, so we can say the circuit is wrong, or some parameter value we have to change to convert into the negative. Understood?
The circuit is wrong means
Maybe some
it
parameter, some resistance value we change, so we can convert this one into way like here I am getting 4 volt and here I am getting 5 volt.
for the negative feedback, right? For the positive feedback system, this will be correct, right? Is it?
Yeah, for the positive this will be correct, for the negative it is wrong.
Yeah.
And I already discussed that in the operation amplifier, generally mostly we consider the negative feedback.
Yeah. Okay, sir.
Okay, because virtual ground concept is only apply on the negative feedback. Understood?
Yes, sir. Proceed.
Now if I change some resistance value, either the 10k or 1k, in a way, that means in place of 5 volt now I am getting a 4 volt, and in place of 4 volt now I am getting a 5 volt. I change some resistance value, so the voltage will be changed. One is the 4 volt, one is the 5 volt. Now what is the output? A times
Minus times.
4 minus 5, that means minus 8. So we apply a positive voltage and we are getting a negative voltage. That means my circuit will be in a negative feedback. Now I solve this using the previous method we applied. If it is a positive feedback, we can't solve using the virtual ground concept. There are different mechanisms to solve the positive feedback operation amplifier. We will discuss that one in the lecture 4, week 4. Okay, but before that one, we always consider that my operation is a negative feedback. Operation amplifier is in a negative feedback. Understood?
Sir, yes, sir. And as of now, we
Yeah.
always considered the operational amplifier as ideal, right?
Hmm.
We do not deal with
Yeah,
non-ideal. Yeah.
non-ideality we discuss in the week 7. Okay, because in the case of non-ideality, the operation amplifier gain is not a constant. What we consider here is that A is 1 plus RF by R1. Okay, we apply only the DC level, DC voltage. If we apply the AC signal, what happen is that particularly gain is constant for all the frequency, or it will be constant for a certain frequency. So we are not discussing till week 6 that this particularly gain will be dependent on the frequency or not. In the week 7, we discussed that this gain will be dependent on the frequency. If the frequency is changed, the gain is also changes. Open loop gain is also changed. And if open loop gain is changed, closed loop gain is also changed. Okay, so where the non-additivity is come. In ideal case, the operation amplifier gain is constant for all the frequencies, either for the DC, either for the AC signal. Clear?
Yes.
Any doubt you can ask. We are not solving this question. I am just explaining you that input current is zero only for the negative feedback. Okay, but previously what we consider the current across this 1 kilo ohm is also zero, but here one loop is created, one feedback path is created, so current is not zero in that case. Input current is zero, but current is not zero from the 1k. The current will pass through the 10k resistance. Okay, now we apply the positive and negative terminal, so we have to check, we have to set the values of the resistance. So my negative terminal voltage is always higher than positive terminal voltage, otherwise my feedback is a positive feedback, and in positive feedback the solving method is completely different. Clear? Any doubt you can ask.
No, sir.
Pradeepa, any doubt?
No, sir.
Okay, when we solve more questions we will clarify that. One thing is I just recommended you that just go with the KCL, familiar with the KCL, because when our operation amplifier is a negative feedback, we always use the KCL. Only way to solve the operation amplifier question is KCL. So just be more familiar with the KCL, solve some related question related to the KCL. Okay, you already discussed the KCL in EEC and ESTC, I think so. Okay, so just revise that one, so it will be easy to you to solve the operation amplifier questions. Okay, if you have
Okay,
any
sir.
doubt you can ask. No doubt, so we will stop here. Thank
Sir,
you
in
all.
the
Yeah,
sir
Thank you,
in
sir.
the voltage dependent voltage source,
yeah.
like in the lecture we professor discussed
Mm-hmm.
in one of the lecture the
Yeah.
voltage dependent voltage source, how to
Mhm.
deal with.
How we solve that one? Okay, how
Yeah,
we
yeah,
tackle
just
that one? How we tackle that one? Okay, so basically, if I
not
Hmm.
not how to solve the how means the concept behind.
Okay, so we apply the input voltage. We are saying my output voltage V naught is A times V1 minus V2.
Like I am confused with the like representation,
Okay.
like where, in the circuit in the lecture sheet draw something like VE
Okay, we will
and
discuss that particularly that in the cover in the lecture. Okay, in the next class. But the concept is that we are getting V out is equal to A times V1 minus V2.
I am not asking about this one. Like
No, I am telling you why we call the voltage control voltage source. Okay, but the part of the lecture that we cover, we will cover in the next class.
okay,
Okay, why we call the voltage dependent voltage source? Because your output voltage is dependent on
input.
Hello.